Hello everyone, my name is Solari. I'm the treasurer for the rigging union, and today I'm going to be doing a quick presentation on IKFK switches. I'm going to be starting from the very basics and showing you two main ways of setting it up. So before we start, I'll just go ahead and go over the difference between IK and FK and the reason why you want to be able to switch between the two. So I'm not sure if you remember our presentation from last quarter, but basically when we're dealing with skeletal animation, when we're rigging a character that's biped, quadruped, anything that's going to have joints in it, there's two main ways that those joints can be connected. So one way is with forward kinematics, which is basically where the children will follow the parent. So if you rotate the parent joint, then the children will rotate around that pivot. The other way to go about having your joints is through inverse kinematics. And this can be helpful when you want to animate something very important on a character, like let's say a hand or a foot. You want to be able to animate from the child of the joint chain as opposed to the parent. So if you didn't have inverse kinematics, you would basically have to rotate from the top, go all the way down to the bottom, and the animator would end up doing something called counter animating, which is something that you don't ever want to do. So inverse kinematics makes it a lot easier. Let's say you have a 3-joint chain. You can take the joint at the very end, and when you put an IK handle there, moving that IK handle will drive the rotation of the joints going up the chain the opposite way. So this is mostly used when we're talking about biped characters. We'll use it for arms and legs, sometimes spine too, but for now let's just focus on arms and legs. So I could go ahead and build a simple joint chain real quick. So let's see, where's our outliner? Okay, so yeah, we have 3 joints right here, and let's go with an arm today. So we're gonna have a shoulder, an elbow, and a wrist. And one thing that I haven't touched on just yet is the importance of having an IKFK bind setup. So you want 3 joint chains. Having 3 joint chains will allow you to have 2 different ways to manipulate your joints. So you have an IK mode, an FK mode, and then you have bind result mode. So the result will just read in which one to use. That way you can blend between the two. So in order to set that up, what you would do is you would first place your joints with the bind joints. So you would start with the bind joints, and when you're setting up something that's going to be using IK, especially rotate plane solver. So I'll touch on this real quick, but when you're using IK for your joint chain, there's 2 different types of IK. One is single chain, and then one is rotate plane solver. So this is actually very important. When you're using rotate plane solver, you need to make sure that all the joints are aligned with one another. So let's say you have this arm right here. You want to make sure that when you look at it, you can see everything is on one plane, no matter how you rotate it. What you don't want to do is you don't want to have a joint chain like this, because when you do that, it's going to mess up the rotations of your joints. When you're building IK and FK2, you want to make sure that your joints don't have any rotations on them, especially for IK though, because with IK, if you want to go ahead and add a pole vector to control the position of the middle joint, it's going to go crazy if you don't keep it in this single plane. So just build this right. You build this, we could consider this an arm right here, and we could even bring it down a bit just like this. So let's say it's kind of in A pose. We have our joints right here. Let's go ahead and make sure to freeze all of our transformations, mainly just rotations. We need to freeze the rotations. And now we have a joint chain. So this is very simple. We have our bind joint chain, our result joint chain. From here, if you want to do an IKFK switch, all you would need to do is just go ahead and duplicate these twice. And when you duplicate them twice, just go ahead and rename them. So the bind joints will become FK and IK. So we have our FK joint chain, and now we also have our IK joint chain. So from here, there's two main ways of setting up your IKFK switch. The first thing we do need to start with are controls, and we also need to have a switch control that's separate from the individual IK controls and the FK control. Or sorry, IK controls, single IK control and multiple FK controls. So real quick, what we can do is let's go ahead and create our FK controls. So what I like to do is I like to put a offset group over all of my controls so that way I can just match them to the joints right away. So let's start with the FK. So FK is going to have a control for each joint because you want control over each individual joint. So we have our first right here. This is going to be our shoulder, and you can just go up here and match all transformations. And since we didn't delete history on these controls yet, we can just go ahead and make sure that they share the same. Oops. Or did we? Oh, we duplicated. Okay. So real quick, let's go ahead and change to, there we go. And let me just make sure, okay, yeah. So that should work. I'm gonna rename these later, but for now, let's just go ahead and match them. Okay. So now we have our FK joint chain right here. These can be our FK controls. And then this can be our offset group. And even if you're not doing an IKFK switch, it's still a good idea to set up your controls like this just so that you have more flexibility when creating connections in your rig. Then this will be the last one right here. Now for IK, all we need is an IK handle and a pole vector. So we have our FK control group over here, and let's go ahead and just group our joints real quick. We have our joints over here, and we have our controls right here. So these are our FK controls. They could go in their own group. So let's look at our IK joint chain. So when setting up an IK handle, like I said, you need to make sure that your joint chain is on a single plane. And when I say single plane, let me go ahead and try to visualize that for you. So when I say single plane, I mean that you have a plane right here, a polyplane. Let's go ahead and snap it to each of these joints. And as you can see, when I snap them, the plane is level. The middle, okay, here's a good way of explaining it. So the elbow joint is on the same plane as the first joint and the last joint. So make sure that you always set up your IK joints like this. And one thing that you may have to do is you may actually have to go here and make this right here your preferred angle, rotating in the negative Y right here, possibly. Just because if you have a joint chain that's almost straight, Maya may not know which way you want to bend. So we put quite a bit of bend in this one, so I don't think it'll be an issue. But let's go ahead and make our IK chain. IK. Let's just go ahead and, so we don't put it on the wrong joint chain, let's go ahead and go into isolation mode. And let's go up here to rigging and go to skeleton. So we're gonna create an IK handle, and we do want a rotate plane solver because we want the pole vector for our elbow. So let's go ahead and place that first on the shoulder and then on the wrist, and there we go. So we have our IK handle right here, and you can see there has been an effector applied right here to the end of our IK joint chain. So let's go ahead and rename our IK handle and do the same thing for our effector too, just so that we know what everything is in the outliner. So from here, what you can do is you can go ahead and let's make an IK handle group, even though we're only going to be having one IK handle in the scene. But so right here, let's go ahead and make a control that will be point constrained to this IK handle. So we can just go ahead and create another control real quick. And when we do this, we can just go ahead and name it correspondingly. So we have our IK control right here. And then we put a group on top of it. And putting a group on top of it will allow us to just go like this. And actually, let's go to the wrist IK joint because we do want the same orientation. So let's click on this control group. Let's click on the IK joint and then go up to modify, match all transformations, and it'll snap it right where it needs to be while keeping your controls zeroed out. So from here, what we can do is let's just change the shape a little bit just so it looks slightly different. And before we do that, let me just make sure it's in the right direction. So yeah, let's go ahead and change the shape a bit. Now, when you do the IKFK switch, we're going to set it up so that the controls will disappear. So when you're working in IK, you'll only see the IK controls, and when you're working in FK, you'll only see FK. The way that we're going to set it up, you will be able to see both if it's at 0.5. So if you want half FK, half IK at the same time, for whatever reason, then you can technically use both controls at the same time, and they'll both affect each other the same percentage. So let's go ahead and shape this a bit differently. It should be good enough. So let's make it a bit bigger too. Okay, yeah. So we have our wrist IK control, our wrist FK control, our elbow FK control, and our shoulder FK control. So now the only thing that we're missing is our pole vector for our IK joint chain. So let's go ahead and create that pole vector real quick. So when creating the pole vector, this is actually a very helpful tip. You can use it for pretty much any 3-joint chain. So let's go ahead and bring our plane back real quick. And when we bring our plane back, we can go ahead and snap. Well, first let's make it a triangle because we don't need 4 vertices, but we just snap the 3 vertices to the position of each joint. And one helpful tip that we can do is we can just change the move tool to go on the normal axis orientation. So when we do that, it's going to follow the same plane as our joint chain. So then we can just drag this back right here wherever we want our pole vector to be. And as you can see, everything's on a single plane. Now you can go and let's create a pole vector control. And the pole vector can be anything you want it to be. It actually doesn't, yeah. Let's just go ahead and have it facing the world. So this is going to be our pole vector control. And then we can go ahead and just match the translations to this vertex right here. So we can isolate these two, grab the group, and we don't actually need to rotate it. Also, yeah, make sure if you ever switch your move tool to normal, always switch it back to object or world because you won't be able to manipulate it in the viewport. So let's go here, and this is where our pole vector is going to be. And let me just change this real quick. So pole vector, it'll just allow you, if you're not familiar with it, it'll just allow you to take the middle joint and you can move it wherever you need it to be. It's very helpful when you're trying to get the knee or the elbow to face in a specific way, especially if you're dealing with a human character and you're bringing the wrist all the way over to the other side of the body. You may need to just point the elbow in the right direction. So let's go ahead and set up our pole vector. So for the pole vector, we have our control exactly where it needs to be, and we can just go to the IK handle and we can go. Actually, first, let's go ahead and take our IK control and point constrain it to the handle so you can see it moving. So we have our point constraint right here, and now when you grab this control, you can see that the IK joint chain, let me hide everything else. There we go. So now you can see the IK joint chain is moving. You can move it however you want it to. So now let's add that extra control that will allow you to move the elbow. So we have this pole vector control. We can go ahead and go to the IK handle, and all we're going to do is just use pole vector constraint. Pretty straightforward. And as you can see, because we placed our pole vector exactly where it needs to be along the axis of the rotate plane solver, our rotations on our IK joints stay zeroed out, which is something that you want. You don't want your pole vector causing your IK joint chain to rotate. You don't want that happening. Because when we switch back between the IKFK switch, we want it to stay stationary. We want it to stay in the bind pose. So now this pole vector, let's go ahead and, we have our IK controls right here. Create an IK control group. So now we have IK and FK. When we isolate to IK, you can see we have our IK control, and then we also have our pole vector control. So this is everything that we'll need. Now we have all of our controls. Now it's time for us to create the actual switch. So, real quick, let me go ahead and create a placement control that will allow you to move everything. So no matter if you're an IK or FK, you can just go ahead and, this would be part of a larger part of the, this would be part of a body if this was a character, but for now, since we're just dealing with one joint chain, I'll create kind of like a placement control for the entire joint chain. So we could just take this control right here, name it placement control, and we could just scale it up, and let's go ahead and create a group for it so we can move it a bit closer, and then yeah, something like this. So now we should have the ability to be able to move our entire joint chain regardless of IK or FK. And then all we would have to do is just place these controls under it. There we go. So we've connected our IK, but what we haven't done is we haven't connected our FK. So for the FK, we can just do a parent constraint. So we'll isolate into our FK controls and our FK joint chain, and we'll just do a simple parent constraint. So we can go up here, constrain, parent, or oops. So yeah, when you're doing parent constraint, make sure you go up here, and we want maintain offset, translate, and rotate. There we go. So let's go ahead and do that for all the joints. And FK is pretty straightforward, which is why I didn't do it first. I saved it for last. But one important thing is that we need to make sure that we have our control hierarchy matching our joint hierarchy. So that way we can move each joint along the, oops, don't grab the joint. Yeah, so now we can move each along. Even though the elbow is really only going to rotate around the y-axis, so we could actually lock and hide the other axes, because you won't actually be able to do this. The twist we could keep, but let's just focus on the overall chain for now. So we have this going on. Now, let's just make sure that this is working. Okay, yeah, so one thing about IK is that we are going to have to put this right here. We have our shoulder IK joint right here. It's going to stay in place because nothing's controlling it. So let's just go ahead and match our shoulder IK. Not match it. Let's go ahead and just do a parent constraint right here. And now we should be good. Yeah. So, oops. Okay. Let's not do that. So when we did the parent constraint, what happened was it froze the entire IK joint chain. So instead of doing that, we're gonna deal with that a bit later, but right now let's focus on setting up the IKFK switch. So for the IKFK switch, we can go ahead and create a separate control for it, somewhere around the end of the joint chain. So let's put it close to the wrist. And then we can just snap it to the wrist. And then from here, let's go ahead and shape it to something else. Something like that. And then, there we go. If we keep the pivot right here at the wrist, that will allow us to have this group right here be constrained to the bind joint, so that way no matter if you're in IK or FK, your switch will always move with your end joint. So let's go ahead and scale this up a bit. Let's see. We can change the shape later, but for now, this will be our IKFK switch. So what we need to do is we need to create an attribute. So normally when we're doing our attribute for IKFK switch, we'll just do something called, we could call it ICableIn. So when ICableIn is at 0, the joint chain will fully be an FK. When it's at 1, it'll fully be an IK. And we don't really need to move this control, so let's go ahead and lock and hide everything else. So all we have here is ICableIn. And now, just to see if this works, you can see when we're going to move our bind joint chain, the IKFK switch will always stay with the wrist. And let's go ahead and change that to point constraint because we don't need it to rotate. So we have our wrist bind joint. Let's go ahead and just do a point constraint. And that way when we end up moving our result bind joint chain, it will always stay forward facing. So there's two main ways to set up our IKFK controls. And actually real quick, let me change the color just so that we don't get too confused. So let's make our IK controls, or sorry, let's make our FK controls. We can make them just like a RGB blue. Let's do that. And then we can make our IK controls, let's make it cyan, just so we can see the difference in the outliner. And let's do the same over here. There we go. Then we can have our placement control down here. Okay, so this makes things a bit easier to follow. Let's go ahead now and talk about the two different ways to go about making an IKFK switch. So there's two main methods. One is a bit more preferred than the other, but it also depends on what type of rig you're trying to build. So the first method that you may have heard of when doing an IKFK switch is simply using a parent constraint. So when you set up a parent constraint, you can have two parents going into a result object or node. So what I mean by that is, let's take this bind joint right here, this shoulder bind joint. What we can do is we can say we want a parent constraint where the parents are going to be both shoulder FK and shoulder IK. So when we do that as our parent constraint, what happens is we have this down here in our channel box. So we have a parent constraint, and going into the node are two different targets. So we have a target for the FK joint and a target for the IK. In order for us to set up our FK IK switch, what we're going to do is we're just going to go into the node editor and we're going to say when this IK blend attribute is 0, then that's what the target value for IK is going to be. And FK is always going to be the reverse of that. So that way the two totals will always equal 1. So this is a really simple way to do the IKFK switch. Depending on how complicated your rig is though, you may not want a bunch of parent constraints. It may end up making your rig a bit heavier, but for now we only have 3 joints in our scene. Technically 9, but it's not a heavy file, so let's go ahead and just go with this method first. So in order to do this, we're just going to set up a parent constraint for each bind joint, so like we did for our IKFK, or sorry, like we did for the shoulder. Let's go ahead and do that for the elbow. We're going to do a parent constraint, and then we're going to do the same thing for the wrist. So we have wrist FK, wrist IK, and there we go. So now that we have this set up, we're ready to go into the node editor. I'm not sure if you've ever been inside the node editor before, but basically this allows you to see everything in your Maya file. Every single node that may not even be visible in your outliner, but it allows you to make connections a lot easier. So what we're going to need is we're going to need this attribute from the IKFK control, and we're going to need the parent constraint nodes that we just set up. We also are going to need the visibility of our controls, but we need to grab their shape nodes. Like you see right here, this shape node we can hide without affecting the children of, let's say, our FK joint chain. So let's say for whatever reason you wanted to hide a single control on your rig, you would have to hide it from the shape node, because if you don't hide it from the shape node...
Excuse me. Sorry,
Oh,
I gotta pull a jump drive from behind.
Oh, yeah, you're fine.
I hope it doesn't mess you up. I don't think it does. Okay, thanks.
So yeah, you want to hide your controls on the shape node, so that way it will hide irregardless of your hierarchy. So let's say you want to hide the shoulder control for whatever reason, but you don't want to hide the elbow or wrist. You would have to hide it from the shape node, because the shape node isn't part of the overall control hierarchy. So right now we have our parent constraint nodes. Let's go ahead and separate those and expand them a bit. And all we have left to grab is our shape nodes. So we just grab these controls right here. And one good thing about the node editor is that when you press this right here, it will add your selected nodes to the graph. And when you're dealing with shapes, it'll add the transform node and the shape node underneath it. So we don't need the transform nodes, all we need is the shape nodes, because we're just dealing with visibility. And you see when I press H, let's press H on shoulder, only the shoulder hides, even though it's children or wrist and elbow. Same for the elbow. So let's go ahead and bring these down here. And all we have left to set up after this is something called a reverse node. This reverse node will just make sure that the IK and FK will always equal 1. So we have our reverse right here. So let's go ahead and name it real quick. So what this reverse node does is it looks at the value of IKBlend. So when we set up IKBlend, this is very important. We need to go into our attribute properties. So we could have done this while we were creating it. Actually, I did. Okay, yeah. I did it while we were creating it, but I didn't explain it. So what you need to do is when you're creating your IKFK blend, you need to make sure that your value has a minimum of 0 and a maximum of 1. This way, when you set up your reverse node, it'll always know what the opposite value is. So we have this right here. And let me just show you one more time how you would set it up. When you're creating your attribute, you go to add attribute, and you can set a maximum and minimum right here. So you would just set 0 as your minimum, 1 is your maximum, and keep it float so that way you can have decimal values. You don't want to be able to only be at 0 or only be at 1. You can set it up like that, but the blend just allows you to have more flexibility. So we have our IKFK reverse right here. Let's go ahead and not deal with that right now. We only use that for our FK targets. For our IK targets, we can just plug these right into our parent constraint nodes. So our shoulder IK, this should become 0. Our elbow IK, this should also become 0. And our wrist IK will become 0. As for the FK, that's when we're going to plug this IK blend attribute into our reverse node. So we can just plug that into our first input out here, and the output should result in a value of 1 since IK blend is at 0 right now. So let's see if that's the case. We go to shoulder FK and it stays at 1 as it should. Same for elbow and also the wrist. And now what you'll see is that when we switch between the two, let's go ahead and hide our elbow bind and our wrist, or sorry, hide our elbow IK shoulder. Sorry, we're gonna hide our FK joint chain and our IK joint chain. So now we can only see our bind joint chain, the result joint chain. And we don't need to see the IK handles either. So actually let's just go ahead and keep it like this. So right now, our ICableIn is at 0, so the FK controls aren't going to be doing anything. Oops. Let's see real quick. Okay, I told you wrong. ICableIn is at 0, so our IK control shouldn't be doing anything. So we grab our IK controls, nothing happens. We're grabbing our pole vector, nothing happens. However, when you switch to you switch the ICableIn to 1, it's going to fully follow IK. So up here, you grab your FK control, it no longer works. One good thing about the blend though is that let's say you have your FK all the way over here and your IK all the way over here. Now what you can do is you can create a blend where, depending on what the value is, it'll go from here to here. And some animators use this especially when they're switching from IK to FK, so it's always helpful to have this as opposed to just a hard switch. And now all that's left to set up is our visibility for our controls. Because as you just saw, the controls don't work when the IK blend isn't set to the correct value. So if it's not going to be usable, let's go ahead and hide it so the animator can tell what mode they're in. So one thing that we did forget was we forgot our shape nodes for our IK controls. So let's go ahead and bring those in. We don't need the transform nodes, only the shape nodes. And I guess I should just mention this one more time, but whenever you create a NURB shape, it's going to have two nodes. It's going to have a transform node and a shape node. And you can actually see this in the viewport, in the outliner. So let's go to our IKFK control right here. For an example, you go to display and you want to display shape nodes. And as you can see, everything that's visible in the viewport will have a shape node. So let's go back out to the node editor and we have our visibility. So the visibility for the IK can just be plugged in right away, just like we did for our parent constraint nodes. But for FK, we're gonna have to plug that through our reverse node, like we did for our FK targets. So let's go ahead and plug these in. And now when we go out of the node editor, we should see that our FK controls will disappear when we change to IK, and our IK controls will disappear when we change to FK. So as you can see, we are in our IK blend right now, set to 1. We're in IK mode, now we're in FK mode. So this allows us to go like this. There we go. So that's the first way to set up our IKFK blend. And before I show you the other method, yeah, here we go. So now you can see this is our placement control. No matter where we put the placement control, we can always switch between IK and FK because of the way we set up our hierarchy. So let's say you have the joint chain rotated, something like this, and you still want to be able to use IK and FK. You can still do that. So one thing that we didn't set up though is, and it's not too important for this, but let's go ahead and make sure that our IK joint right here is, let's make sure that this is following the placement. Oops. Okay, that was a problem. So we didn't have maintain offset turned on. There we go. Oops. I chose the wrong one. Let's go back up here. There we go. Let's make sure that the IK is still working. Yep, there we go. Okay, so this was the first method to set up our IKFK joint chain. The second method is, it's a bit more involved, but it's actually lighter on the file. So this first method that we used right here involved, let's look at the node editor real quick. It involved 3 parent constraint nodes and a reverse node. So the reverse node isn't really the problem. The problem is that we have 3 parent constraint nodes, and like I said, depending on how heavy your rig is, you may not want to use parent constraint nodes at all. So, or you may want to use them as little as possible. So let's go ahead and take these connections that we made, and let's unconnect them real quick. So let's go here and break these connections. And you can actually do this in the channel box too if you want. You can just go up here and break these connections. And there we go. So the wrist, the elbow, let's break these. And then we can do the same thing for the shoulder. So we no longer have our FK-IK switch. Let me show you a different way how to do it. One way that we can do this is we can use something called a blend color node. So this blend color node, basically what it does is it looks at the value of the IK blend attribute. And when we do this, we're gonna have to set up a few more nodes, but these nodes are lighter. So with the blend color node, what we're gonna do is we're gonna have a blend for our translation and our rotation. And if you have scale set up in your joint chain, we would also do that too. That's not really an issue for us, so let's just look at translation and rotation. So when we're doing this, we're gonna need two sets, one for translation, one for rotation, because the way that blend color works is you have color 1 and color 2. So the blender is gonna be kind of like the switch, the value. I'm not sure, if you use some Adobe software like Photoshop, maybe even After Effects, you may be familiar with blend color possibly. But basically the idea behind it is, let's say you have two separate colors, like two distinct colors, two different hues, and you want to blend those colors together. You can do that using this simple node. So our IK blend is going to be our blender. So when our blender is at 0, it's going to read color 2, which will be our FK. When the blender is at 1, it's going to read color 1, which will be our IK. So let's go ahead and rename these real quick. So this can be our translate, and then this will be, oops, what did I do? Oh, I tried to copy and paste. Let's not do that. So let's go ahead and, there we go. This will be our rotate. And let's just go ahead and do scale too, even though we're not going to be scaling our joints, just to show you how it would work. So we have our translate, rotate, and our scale. So let's go ahead and move these over here. We aren't going to be using these parent constraints anymore, and we actually should go ahead and delete them. So let's go ahead and delete these. So now our bind joints are no longer getting any incoming values. So the bind joints won't move anymore. So let's go ahead and look at these right here. You have our translate, rotate, and our scale. And going into the blender will be our IK blend. So we have this right here. And for color 1 and color 2, we're actually going to be plugging in the translation and rotation values of our IK and FK joints. So we are going to bring those in. We have our FK joints right here that are parent constrained, then we have our IK joints that are associated with our IK handle. We bring those in, and these are going to be the values that we use for color 1 and color 2. So we have these joints over here. Let's expand these real quick. And like I said earlier, with the blend color node, color 2 is the value associated when the blender is at 0. Color 1 is associated with the value at 1. So we look at color 1 and color 2. This means that for our translation, rotation, and scale, we need our shoulder IK to go into color 1. And we need our shoulder FK to go into color 2. So let's go ahead and put these in. Shoulder FK will go into color 2. And one thing that can be annoying about the node editor is that it auto-generates nodes for you. So you're going to see this in a bit. But let's take our elbow IK, or not elbow IK, let's stick with the shoulder. So we don't have enough nodes. So let's go ahead and create a few more. So what we're actually going to need is we're going to need shoulder, translate, rotate, scale, elbow, translate, rotate, scale, and wrist, translate, rotate, scale. So we can just go ahead and duplicate these 2 more times. This is going to be our elbow result, and then this will be our wrist result. So it is more nodes, but these nodes are still, even in their sum, they're lighter than 3 parent constraint nodes. So we have, this will be shoulder, this will be shoulder, oops, we don't need that much, just shoulder, and another shoulder. And let's go ahead and do the same thing for our elbow. So we have our elbow nodes down here. Let's go ahead and copy those over. And last we have our wrist nodes. So for the wrist nodes right here, let's make sure we rename those. Oops. And then we have our scale. So now we're ready to make our connections. So let's go ahead and, oops, let's line these up. So we have our elbow translate, our elbow rotate, elbow scale, but we're still dealing with our shoulder right now. So let's go ahead and expand all these just to make things easier for us. But what you are going to see is that when we connect our rotate, it's going to create a unit conversion node. And this is something that you can avoid if you script this process or if you do this process with the node editor closed. So let's go ahead and go to our shoulder rotate, and you'll see what happens. We plug the IK into color 1, and look at that. So what's happening is Maya has a way of calculating its translation, rotation, and scale values. Translation is fine, but for rotation and scale, it uses a bit different method involving matrices, so that's why this unit conversion node is necessary. But it shouldn't mess up our stuff too much. Just know that going forward, if you're doing a lot of connections in the node editor, it may be easier actually if instead of dragging those connections around, you just kind of script those things, so that way those nodes are all generated for you and you can sort them out later if you want to go in and see how everything's working. So we have our shoulder rotate. Let's find our shoulder FK right here, and for now it's still pretty clean. Let's go shoulder FK, color 2. Okay, so we have our translate, our rotate, and now let's get our shoulder scale. So for our shoulder scale, let's go ahead and, is this our scale? Yep. Our shoulder scale should be going right here, and then we have another shoulder scale coming in here. Shoulder scale. Oops. Let's plug this in. Okay, so yeah, we have our shoulder translate, rotate, scale. Let's do the same thing for our elbow. We need our elbow translate, rotate, scale all the way down here. So we have our elbow FK, our elbow IK. Let's find these real quick. There we go. Elbow FK, elbow IK. And translate, rotate, scale. Our translate will be going into color 1. And actually, yeah, let's make sure that the blender is set for our elbow and wrist. So we have our blender right here. We have our blender, and it's going to be going into each one. And then we have our wrist. So now let's go ahead and continue our process of going and setting up the blend. So we have our elbow FK going into color 2. Our elbow rotate, let's get that. It's gonna go into color 1. Oops. And we should still be able to find everything. Elbow FK is up here. Color 2. Okay. So now all we have left is elbow translate, elbow rotate, elbow scale. Let's get our elbow scale. We have our elbow FK and IK all the way up here. Let's try to bring that back down. So we have our elbow IK scale. Scale will be going right here. And then let's get our elbow scale for our FK joint. Okay, so now all we have left is our wrist translate and our wrist rotate and our wrist scale. And actually, yeah, I did it wrong. Let's not plug these into here. This scale should be going into elbow scale, not wrist scale. And then let's plug this up here. So now all that's left is our wrist. So let's grab the wrist joints, which should be right here and right here. And you can actually avoid this if you want to by pinning objects. So I probably should have shown this sooner, but let's say we want to pin everything right now. We just select this right here and we go up here and go to pin. So when we pin, it will keep the position of the nodes inside the node editor locked. So no matter what new nodes may get auto-generated, it won't change the position of the nodes that you have pinned. So we have our wrist IK. It's not going to be a problem for translate, but for rotate it will be. So wrist IK, let's go ahead and plug that into translate 1. And then we have our wrist FK down here. Now let's go to our wrist rotate and let's see if it works. We have color 1. Oops. Color 1. And yeah, as you can see, everything stayed put except this unit conversion node. So we could just pin everything again if we wanted to. Let's pin that. And then we can go to wrist FK. Wrist FK for our rotate. And let's get that going. There we go. And we have this unit conversion node all the way down here. And this only happens with rotate. For translate and scale, it's fine. So we don't need to worry about pinning anything else. We can just go wrist IK scale, that goes into color 1, and wrist IK scale, that will go into color 2. So now we have our blend set up, but we need to plug it into our result joints, our bind joint chain. And this process is pretty much the same as we did last time. So as you can see right now, nothing is moving the bind joints. If you look at the IK and FK, things are moving because we still have those connections, but not for the result. So to get the result going, let's go ahead and bring our bind joints back in and plug those blend color nodes into them. So here we go, up here. We have our shoulder bind, our elbow bind, and our wrist bind. And it looks like we're actually going to end right at 4, which is good. I wasn't sure if I'd be able to make this last a whole hour, but let's go ahead and go to our bind joint right here. We're going to plug the translate output into our translate values. We're going to plug the rotation into our rotation and the scale into our scale. So let's go ahead and pin everything again because we know what's going to happen with the auto-generated unit conversion node. Let's go up to shoulder rotate. That'll go right here. There we go. You can see that unit conversion node all the way down here. And then let's go ahead and plug in the scale. So we have our shoulder scale right here. Let's get that going. And yeah. Oh, sorry. Yeah. So we have our shoulder scale. And now let's go to our elbow and wrist. So for the elbow, it's down here. Let's go up and plug these in. Elbow translate, elbow rotate, and elbow scale. And last, we have the wrist. So for the wrist, let's go ahead and pin everything one last time. And we have our wrist blend color nodes down here. The wrist blend color nodes, let's drag those up. And we can just plug in translate, rotate, and scale. So let's make sure that these are going in the right place. Translate, rotate, and scale. So now when we look at our bind joint chain, everything should work the same. There we go. We have our IK moving, and we have our that's still IK. We have our IK moving, and we also have our FK moving. And there will still be the blend in between the two. So let's take our shoulder right here, let's bend it, let's bring it back to IK, and you can see the blend is still happening. Look at that. And like I said, when we're at 0.5, we'll be able to see both of them just because of the way we set up our visibility. But I doubt that this will be used for actual animation, more just for kind of like setting up a good interpolation process. So with that being said, this is how you would go about setting up a simple IKFK switch. And there's two different methods. The second one is more preferred, but if you have a more simple rig, you could probably get away with using the parent constraint method. So if nobody has any questions, that's pretty much it for today. Thank you for listening, and I'll make sure to stick around just in case you want to learn anything else resulting from FK or IK. Thank you.
Thank you, everybody.